Good morning, students. Today we are going to discuss about some terms related to a sound wave. The terms which are associated with with a sound wave are amplitude, frequency, time period, and frequency. We will discuss about each term in detail. So have you ever seen that if you throw a, a pebble or a stone in the water, it creates ripple in the water. That ripples are actually waves. But that waves are actually water waves. If you draw that ripples, the that will exactly look like this one. Okay, so this is a sound wave or this is a general wave. Okay, so you can clearly see that this wave, this is the highest point of a wave, and this also a highest point of a wave. The highest or topmost point of any wave is called crest. Is called crest, and you can see this is the lowest point of this wave. Okay, the lowest point of any wave is called trough. The lowest point of any wave is called trough. So what is a wavelength? Wavelength is the distance between two consecutive crests is called wavelength. So this is a crest and this another crest. So the distance between two consecutive crests, that means this length, is your wavelength. Or you can say that the distance between two consecutive troughs are also called wavelength. So this distance, this is a trough and this another trough, so this distance is also your wavelength. Wavelength is denoted by Greek word lambda. So this is a wavelength, this is also your wavelength, and these two distances are equal actually. So the definition is the distance between two consecutive crests or troughs is called wavelength. So what is amplitude? So first you have to know what is mean position. So the dotted line, you can see this dotted line is your actually mean position. So mean position means an imaginary line which cuts the wave into two equal parts. You can see that this line cuts the wave into two equal parts. So this line is your mean position. This is an imaginary line. Now the amplitude is the distance, the the maximum displacement of the wave from its mean position is called amplitude. Okay, so which one is the maximum point of this wave? This one is the maximum point of the wave. So the distance from the mean position to the maximum point, that means crest, is called your amplitude. So this distance is amplitude. Okay, so this distance is amplitude. So since amplitude is a distance, so its unit is meter, and amplitude is denoted as a, and its unit is meter. Well, since amplitude is a distance. Now frequency. What is frequency? Frequency means the number of vibrations produced by a vibrating body in 1 second is called frequency. Now I am I'm producing a sound. That's why you can hear my voice. How can I produce a sound? Because my vocal cord is vibrating. My vocal cord is vibrating. Okay, so in one second, how many times my vocal cord is vibrating is the frequency of my vocal cord. Suppose in 1 second my vocal cord is vibrating 100 times. So the frequency of my vocal cord is 100. So if frequency is denoted as a small f, and its unit is hertz, 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 and it is denoted as hz. Okay, so the unit of frequency is hertz. Now time period. So time period means time taken by a particle to complete one vibration or one oscillation is called time period. So suppose my vocal cord is vibrating 100 times per second. Okay, so my frequency is 100. So for one vibration, how much time it takes is called time period. So if in 1 second my vocal cord is vibrating 100 times, so for one vibration it will take how much? 1 by 100, 1 by 100 second. Okay, so time period, so unit of time period is seconds. Unit of time period is 10 seconds. So time period means time taken by a particle to complete one vibration or oscillation is called time period. So the relation between time period and frequency is T is equals to 1 by T is equals to 1 by F. Time period is equals to 1 by frequency. So if your frequency is given, suppose 50 hertz, then suppose question is find the time period, then then you have to just put the value of F. So value of F is how much? 50, and the value unit of time period is second. So time period is equals to 1 by 50 second. Okay, so in this way you have to solve the problems. So just remember the relation is time period is equals to 1 by frequency. Now there are some types of sound. So in every day you hear many types of sound. Okay, some sounds are very good, or some sounds are very pleasant to hear, and some sounds are very unpleasant. Okay, so depending upon their pleasant or unpleasant, we can categorize the sound into two parts. Into one is called musical sound, other is called noisy sound, or other is called noisy sound or noise. Okay, the musical sounds are very pleasant to hear, and they produce by regular vibration. Okay, so for example, the sound of flute or sound of any musical instrument is a very is a musical is a musical sound. So here you can see this way, this is your musical wave. Okay, so here you can clearly see the amplitude of this musical wave is same. So amplitude of each wave. Okay, so the amplitude of this one and this one are same, amplitude of this one and these two are same. So amplitude of a musical vibration are same, and the frequency is also same in case of musical sound. But in case of the noise, in case of noise, they produce by irregular vibration. So for example, the sound produced by vehicle, or sound produced from a horn is example of your noisy sound. Okay, they produce by irregular vibration. If you saw the graph of noisy sound, so this is your noisy sound. So you can clearly see that the amplitude is different. So this one has high peak, this one has the low peak, this one has very low peak. So that means the amplitude is very different, and the frequency is also different, because two waves, so suppose this is a wave, this another wave, wave, the separation between two waves are not same. That means their frequency is also different. So in case of noisy sound, they have different amplitudes and different frequency, but in case of musical sound, they have same amplitude and same frequency. So what are the difference between music and noise? So first, music is very generally pleasing to listen to, but noise is very unpleasant to hear. The second point is that music is produced by regular vibration in a medium, but noise is produced by irregular vibration in a medium. Okay, so and the third point is the amplitude and the frequency of a music do not change, but amplitude of a noisy frequency, the amplitude and the frequency of a noisy sound, they change. Okay. Now, what is loudness? Loudness means how much energy a sound wave carries. If if a sound wave has higher amount of energy, then that sound wave, then the sound will be very loud. If the sound wave has very low amount of energy, then that sound wave will be less loud, or dull, or feeble. Okay, so loudness means the energy carried by a sound wave. Okay, so loudness of a sound wave relates to the amount of sound energy received by unit area per second. Okay. Now loudness is also depends on amplitude of the sound wave. Now do you know what is amplitude? Now look, here you have actually two waves. In the right side, the amplitude of this wave is high, but in the left side the amplitude is low. Why? Because you can clearly see in the right side the length, the height of this wave is high compared to left one. The left one has the very low height. Okay, so that means here you have a high amplitude, and here in the left side you have a low amplitude. Okay, now amplitude actually represent the amount of energy. It has the higher amplitude, that means this sound wave, the wave has high amount of energy, and in the left side the amplitude is low, that means this sound wave has low amount of energy. Now again, if the energy is high, then the sound will be loud. If the energy is low, then the sound will be less loud. If the amplitude is high, then the sound will be loud. If the amplitude is low, then the sound will be less low or feeble or dull. Okay, so that means if you increase the amplitude, then your loudness will be also increase. If you decrease the amplitude, then the loudness will also decrease. So here in the right side, this sound wave is very loud sound, but in the left side this sound is not very loud, is a dull or faint sound or soft sound. Now loudness also depends on the distance between the source of sound and the listener. Okay, so if you move towards a loudspeaker, the loudness of the sound will increase. Okay, and if you go away from the loudspeaker, the loudness of the sound will decrease. So that means the distance between the source and the listener, as the listener decreases, the loudness of the sound will increase. Now the third point is area of a vibrating body. The loudness of a sound is also depends on the area of a vibrating body. If the vibrating body has a larger area, then the very loud sound will produce. If the vibrating body has a very smaller area, then not then a dull or very small pitch sound will produce. So here you have two pictures. Here you have a very large drum. This drum has a very larger area, so this drum can produce a very loud sound. But here the left side, this drums has very smaller area, so this will produce a this will produce a dull or soft sound. Okay, but here in the right side it can produce a very loud sound. So thank you.